Hey there, traveler, and welcome to the GameDev Tavern. Come on in and stay a while as we craft great little games together. My name is Nicholas, and this is episode 9 of the tutorial series where we create a pixel art beat-em-up game in Godot. So today we're going to introduce a new design pattern called the event bus. So far, we have been manually adding enemies and knives with the editor directly and placing them carefully inside the actors container node so that they can appear in the game. Now this time, we actually want to instantiate those objects through the code directly when the throw animation is played. So the main rule we want to follow here is that every object in the level needs to be added as a direct child of the actors container node in order to be properly Y-sorted. So ideally, the actors container is the perfect node responsible for spawning new things, and we place the instantiation code just inside of that node. The spawn requests are coming from the player and enemy characters, which are direct children of that node. Now remember that in Godot, for children to communicate with their parents, the best practice is for children to emit a signal that the parents can listen to. Parents can call methods on their children directly, but children should use signals to communicate back up. It's best to call down and signal up. Anyways, one easy way to set this up is to have the character scene contain a new specific signals for spawning a knife that gets thrown. The actors container, the parent, can then connect that signal and spawn a knife on demand whenever the child node emits that signal. So while this works well, there are two minor issues with this approach. First, with regards to the separation of concerns, we are now adding signals to characters that don't really have anything to do with the state of characters. Ideally, the only signals that characters can emit are things regarding their own state, such as the health is changing, or they're dying, or other things. So containing signals for spawning independent new objects really mixes the state of the characters with the state of the game. Second, characters are actually not the only objects that will spawn those collectibles. Barrels actually need to do that as well, and perhaps other objects in the future. So these scenes now also need to have their own signals, repeat the same code, and the actors container now needs to also be aware of all of those additional yet similar signals. So there are several cleaner ways to approach this problem, but today we're going to use this opportunity to introduce a pattern called the signal bus or the event bus. And the idea behind the signal bus design pattern is to have a global node object which sits at the very top level of the scene tree and which is always accessible from every single object or script in the game. So those objects will contain signals that can then be listened to and emitted from anywhere in the codebase. So this allows any game object anywhere and at any time to subscribe to global events that can be triggered by any other game objects. So in our case, the actors container will be the one listening to that global signal. And then other objects, such as the character and the barrels, can then call this signal from wherever they are in the scene tree. So those signals become global signals. They don't need to belong to any specific scene. There's no mashup of code with any scenes. So while this may sound complicated, it's actually a very simple thing to set up in Godot, and we will use it as a global emitter of signals for things that need to be spawned. Now, as with every single design pattern out there, the event bus, it has its pros and cons. You'll actually meet fanatics who only live by that design pattern, and skeptics who will avoid it at all costs. The main downside of having global objects, or global signals, or global state in general, is that they can easily lead to additional complexity and spaghetti code due to the fact that they're accessible and sometimes even modifiable by every single object in the game. From experience of being a software engineer for more than 20 years and working on Gmail at Google for the past 10, I can tell you with confidence that every design pattern has its own use case, just like tools in a toolbox. And as long as you understand when and how to use those patterns, you'll usually just do fine. So with that said, let's go ahead and implement this in Godot. So the first thing we'll need to do is to add logic for the collectibles to handle the fly state. So let's hop over into the collectible scene and hop over into the script. Okay, and so here we're going to need to keep track of two additional things. We'll need to keep track of the direction By default, we'll make it a vector 0, and then the velocity. And finally, in the ready state here, by default, we're starting in the false state. So let's make sure that if we kickstart this node in a different state, for example, the fly state, then we'll go ahead and set the velocity to the direction times the speed. All right, and finally, in the process method, if we do have any amount of velocity, we'll just want to move the position of the object by that amount. So velocity times delta. Okay, so now that we have set up those collectibles for them to be able to fly through the level, we need to start adding our global object and connect to those global signals. Go to File, New Script, and then let's call this Entity Manager. And we will go ahead and locate it inside, let's create a new folder and let's call it utils. All right, let's get rid of all of this for now. Go ahead and save and go to project settings, and in the auto load folder, let's locate the file that you just created. Click on open and then click on add. So this creates this object entity manager that is now a top level object. So if I go ahead and run the game, you'll see that when I run the game here in Godot, you now have two folders. The local folder is where we currently work on a daily basis, where we add objects and add scripts and so forth. The remote tab actually indicates the current state of the game. This is where all of the objects of the game live, and whenever we instantiate new objects, they will appear here. You can also inspect the values for those objects, and this makes it very handy to debug game as the game is currently running. And you can pause the game here and then take your time to inspect things. But the one thing I want to call out to your attention is this top level entity manager node, which is this node here that is now accessible by every single object in the game. So we'll give a quick example of something that we can do. But for example, here, let's say we create a function to print something. We can now go to the, let's go to the player scene, and here, when we are ready, we can actually call the entity manager.sayHello. And you can see that there's autocomplete. Entity manager is accessible from everywhere. When I run the game, the player, because it's instantiated, is actually calling that global object sayHello method. Okay, so let's stop this, and we're going to remove this code. Let's hop back over into the entity manager. The main thing that we want to do here is to define this global signal that will be used to spawn entities. And we'll start by spawning collectibles. So let's go ahead and define the signal, and we'll call it spawn collectible. So there's a couple of things that we'll need to pass there. First, we'll need to know the type of collectible. So the type is collectible.type, and the initial state. Are we flying? Are we dropping to the ground? Are we already on the ground? So this is going to be of type collectible.state. We'll also need to know at which position to spawn the object. And for this, we'll be using the global position. So let's call this collectible global position. It's going to be a vector 2. And we'll want to provide a direction to see, like, are we throwing it towards the right or are we throwing it towards the left? So collectible direction. This is also going to be a vector 2. Okay, so now that we have defined this global signal, it's now available from everywhere in the code base. And so we're going to go into our main world scene. And if you remember, the actors container is the node that needs to listen to that global event, and it will be instantiating the object and adding it as one of its children. So let's go ahead and create a new script for the actors container. We could make it its own scene, by the way, and that's always something I like to do, but I think for now, this is going to be pretty straightforward. So let's go into scene stage. This is perfect. So let's go ahead and create it. Okay, let's clear those comments. And in the ready function, we'll want to connect to it. So entity manager.spawnCollectible connect. And here we'll create our own method on spawn collectible .bind. Okay, let's create this method, and we'll want to reuse the same signature as the one that we had defined in the signal. So let's hop back over into the entity manager, And you can just copy this, go back into the actors container, and you can just paste this. We're not going to return anything. But here there's going to be a couple of things we'll be doing. So first, we need to instantiate the class. And in order to do this, we need to have it preloaded. So if we only had the knife, for example, we would do something like this. So we would const knife prefab, and then we'd preload the knife scene here. And then inside this code, we could just do knife prefab dot instantiate. Now this code is actually going to be the exact same. So this is going to return a knife object. And then we can place this knife object wherever we want in the game, and we'll make it a child of the actors container. But this code is actually going to be the same, whether it's a knife prefab, whether it's a gun prefab or whatnot. So the only thing that we need to do to reuse the code is just to make that a little bit generic. So for this, we'll just have a variable where, depending on the type of collectible, we'll just be instantiating a different prefab. So similarly to all of the other dictionaries that we've created, let's call this prefab map. And we will have the collectible.type.knife, and this is where we'll be preloading this. And we'll just keep that one for now, but you'll see that down the line, adding new collectibles is going to be trivial. So rather than writing this, we'll just make it more generic. Collectible is of type collectible. And we're going to go into our prefab map, find the type that we're looking for, and instantiate it. Okay, and then we'll want to set some initial properties for that collectible objects. So the state is the initial state. We'll want to set the global position. And we'll want to set the direction. Once the object is ready to be added to the scene, we'll just add it as a child to the current actors container. All right, so this is going to be it for the actors container, and now we just need to call that signal from anywhere in the code base so that we create this this object. So the main thing is we want to be able to spawn it in the right spot. And if you look at the player object here, when we look at the throw animation, ideally we want the knife to spawn from roughly that position here. And so for this, what we can do is to add a node 2D as part of the character object, just to keep track of where things need to be spawned. So let's hop over into the character scene, and we'll actually make it a child of the knife sprite. So it'll be easier whenever we flip the knife sprite left to right, that position, which will be a child, will also flip as well. It'll make it easier. So let's just create a child node here. We'll make it a node 2D, and we'll call this collectible, or maybe weapon position. All right, let's go ahead and save, hop over to the player, and we're going to move that node to where we'd want to instantiate the knife. So let's try here. Let's see how this looks. Okay, so now that we have a weapon position, we'll need a reference to it inside our character script. So back into the character script, hop all the way to the top. Let's create an onReady variable and onReady var weapon position. This is a node 2D equals weapon position. Okay, we don't need to worry about flipping it on the other side because it's already a child of something that gets flipped if we're heading in the right direction. So the only thing we need to do now is just to spawn it in the right spot. So let's hop over into the onThrow complete. And here we'll want to actually spawn the knife when we get rid of it. So for this, we're going to call the entity manager .spawn collectibles .emit signal. Okay, so there's a couple of things here that need to be added. So first, we need to know what type of collectible. So this is going to be a collectible.type.knife. We'll need to know the state. So collectible.state.fly. we'll need to know the global position. So for this, we'll have the weapon position.global position, and finally the direction, and we already have that as part of the character as a parameter called heading. Okay, and with that done, I think we can try and get started and see if the weapons are flying around. Okay, so the enemy over there is thinking, okay. So the weapon is flying, but first of all, the enemy, we haven't set the weapon position. So let's go ahead and do that. And then also you can see that the weapon needs to, the sprite also needs to flip depending on the direction. But we're pretty close. So let's go over into the collectible. There we go. And in the process here, we'll want to flip the sprites. Dot flip h equals velocity dot x. And finally, we want to add it as part of the enemy. So hop over into the basic enemy. Let's load the animation player, go into the throw animation, and then let's locate the weapon. Where is it? The weapon position. We'll just bring this up towards here. And finally, let's just make sure that we are not just flipping the sprite, but actually scaling it on the x-axis. So if we just flip the sprite here, we're not modifying the weapon position. But what we need to do is actually set the scale.x to -1. So this will both flip the sprite, but also flip the position, invert the positions of all of the children. So let's go into this script, character script, and where we're flipping the sprite, knife sprite. So flip sprites, there we go. Knife sprite, here we'll want to set the scale. -1. Okay, let's try this out. All right, here we can throw the knife to the right, we can throw it to the left. Let's get rid of this guy. And okay, so it looks like it's working, but actually I spotted something odd. Can you spot it? What happened if I go right here? There's two things here that are wrong. First, you'll see that the knife goes behind the barrel. And second, you'll see that the knife doesn't have a shadow. And the reason for that is because we never specify the height of the knife. Actually, we specify a wrong height by not specifying it. Basically, what we're currently passing, if you look at the 2D view, we're currently passing this global position here, which is incorrect. We should be passing the global position of this point right here and giving the height that correlates to this distance, which should be 14 pixels. So we need to add a new parameter to the signal, the global signal, so we can specify an initial height. That way, whenever we throw a weapon, we can, depending on the character and how high the character is, we can specify a different height. So let's hop over into the script and we'll go into the entity manager where we have defined the signal. We'll go ahead and add a new property called initial height. This is going to be a float. And then let's go ahead and figure out wherever we are calling this. Control-Shift-F, go ahead and press enter, and you can directly get access to the character here where we're emitting the signal and to the actors container where we're subscribing to it. So let's start with this. So the unspawn collectible here will have an additional property called initial height, which will be a float, and we will want to set it. So collectible.height equals initial height. Okay, and lastly, in the character scene, we'll want to fix the way that we emit the signal. So we'll need to figure out what are the exact positions we want to set. So once again, we are looking at, let me go back to the basic enemy. We're looking at sending this position for the global position and this distance for the height. So this position for the global position is exactly the global position of the player for the y-axis and the global position for the weapon for the x-axis. So hop over back into the code, into our character script, and let's var knife global position. So this is going to be a vector2, and we'll have the weapons position, the global position.x, and we'll have the current character's global position.y. And then for the height, knife height, here we will use the weapons current local position, so the 14 pixels. And because this is negative, we'll actually want to do a minus here, so we send a positive value, .y. Okay, and lastly, we want to make sure we pass this when we emit the signal. So this is going to be knife global position and knife height. Okay, with that set up, let's go ahead and try this out once again. Okay, and when we throw the knife, you can now see, this guy is a little bit annoying, that the height is properly set. Let's see. And if we scroll over right here, it should go in front of the barrel. And if we go right here, it should go behind the barrel. Okay, this is looking good. Now the next thing we'll need to do is just set up the damage emitter so that it actually emits damage. And similarly to how we had this to set the height of the knife, we'll also need to change the position of the damage emitter so that it maps to the knives. So for example, right now, if I look at the visible collision shapes and I hop over into the knife scene, and I'm going to create an area for the damage emitter. So editable children, let's go ahead and create a small rectangle. We'll make it 3 by 3. And you can see that right now the damage emitter is located where the shadow is, and so this isn't going to map to where our damage receivers are here at the top. Okay, so we'll just need to alter this, and we'll then need to connect to the signals. So let's hop over into the collectible scene and hop over into the script. We'll need to have a couple of additional parameters. First of all, export var damage. By default, we'll have a knife emit 4 points of damage. Okay, next we'll need a reference to our damage emitter. So let's hop over and add an unready variable. This is an area to the damage emitter. Okay, and we will connect to the signal. So when we are entering this area entered, we will connect to a new function. We'll call this onEmitDamage. Let's go ahead and create this function. And this has a damage receiver as argument. Doesn't return anything. Okay, there's only two things we want to do here. We want to let the receiver that they're receiving some special damage and they should be knocked down. And second, we'll want to remove the knife from the scene. So receiver dot damage receive will emit the signal, and here we'll set the amount of damage, the current direction, and the heat type. And finally, we'll want to remove the knife from the game. Okay, and the last thing we'll need to do is making sure that we are looking at the right collision layers. So the damage emitter here needs to look at the player damage receiver and the enemy damage receiver. So damage emitter dot position equals vector2 dot height up time height. Let's try this out. With all of those collision shapes, it makes it a little bit difficult to see, but then we go ahead and remove that. So debug visible collision shapes, and let's try this out. And you can see the character over there got hit with the knife. Okay, so this is now working properly. The last thing we'll need to do is making sure that when the knife is thrown out of the scene view, if it hasn't hit anything, we should eliminate it from the game so that way it doesn't keep on flying forever. And we'll be using our invisible walls on the side to do this. Okay, so the knife's main area is already trying to detect some bodies here with the enemy and the player so they can get picked up. So rather than reuse this, we'll just reuse the damage emitter, which is a second area. Currently, this area only is looking for other areas. So what we'll do is we'll also include the invisible walls, and this is the only body that this will be looking at. So in the code here, we can just connect to the damage emitter dot body. And then here, rather than doing body entered, we'll do body exited, which means that the knife will need to have exited from the invisible walls bodies. So this is because this is the only body that we are looking for. We know that this is going to be the invisible walls. So let's connect, and on exit screen dot bind. Let's go ahead and add this function. This takes a body, which is going to be our invisible walls, and those are uneditable bodies. Let's call this wall. and here we'll just remove the scene from the game. Okay, let's make sure that this works. So let's go ahead and print by, and when we throw the knife to the left-hand side, we should now have a bite, meaning that the object has disappeared. Okay, so before closing the episode, you may have noticed a couple of bugs that are still in the game that we'll be fixing right now. So first of all, let's just get rid of this warning here. Debugger, the parameter wall is never used. So here we'll actually never use this. Let's go ahead and prefix it with an underscore. And then let me show you a couple of bugs that you may have discovered on your own. So first of all, let me just get rid of these. You can see that the hit doesn't always register. And this is because currently okay, and that was the second bug, the player doesn't stay grounded. And also the third bug is that when grounded, the enemies actually still face the player. So we'll go ahead and fix those three things. So first of all, the fact that the enemies are still hit or miss, there's two things we're going to do. First, we'll hop over into the basic enemy scene, and as part of the animation player, currently the hurt animation lasts exactly the same amount of time as a punch from the player, which means that there can be a little bit of a raise condition here happening on that frame. So what we'll do is we'll take this and bring it up by 0.05 seconds. Make sure your snap is on 0.05. The next thing we'll do inside the script is we'll make sure that a character can get hurt when they are preparing to hit. Prep attack. Okay, and so that will fix the problem with hitting enemies. The second problem is that enemies still face the player when they're down. So this needs to be fixed in the basic enemy script. And inside the set heading here, so we want to return early if we are on the ground or if we cannot move. So if we're not able to move, then we'll want to return and not change the heading here. And finally, the player doesn't stay grounded at all. And this might just be the fact that we didn't set a variable for duration grounded. We'll just set this to 1000. Okay, with those things fixed, we should now have something a little bit more polished. So let me get rid of this. And let me make sure that we can hit the enemies whenever. And when they are grounded, they don't face towards us. And then let's make sure that we can stay grounded. There we go. Oh, it's the same thing for us. We also need to make the change inside the character script. So back in the player scene, first we want to make sure that we can actually move. This will prevent us from moving while we're in the ground. And we want to make sure that when we are changing the heading that we can move as well. Okay, so that should fix it. Oh, there's another bug. I don't know if you noticed it. Okay, and here we cannot move. But when another character is on the ground, it's still receiving the damage from the knife. And so we want to make sure that when a player is on the ground that we're not monitoring for the damage receiver. So let's go ahead and fix this. So if you look at the animation player for the player, for example, when we do any sort of attack, for example, when we kick or jump kick, this is when we set the damage emitter to be monitoring at that point. And typically, this is nice so that you can fine tune where you want to start monitoring. Typically, ideally, it's only when the hit is actually starting to happen. And maybe we stop the monitoring right before. In our case, we're keeping things pretty simple, meaning that the start monitoring and we end monitoring at pretty much during the entire state of when the player is attacking. So one way we could just simplify the whole game rather than setting the damage emitter and the damage receivers to the exact same states is we could actually get rid of the monitoring through the animations level and just set it in the code to say, hey, if we're attacking, let's just monitor with the damage emitter. And if we cannot get hurt, then let's just have the damage receiver not be monitorable. So let's go ahead and make this change. I do think it'll be a little bit simpler, but if you want to fine tune the animations and when the contact are happening, feel free to continue to fine tune this and play around with the system. So for now, what we'll do is we'll hop over into every single attack animation. So here in the jump kicking, we'll just remove this damage emitter. In the kick, we'll remove this damage emitter as well. And then in the punch and punch alternate, we'll also remove them. And same thing for round kick. And rather than set the damage receiver within the animation, we'll just change that in the code. So let's do the same for the enemy first. So let's hop over into the basic enemy, into the animation player, and then every single animation, where the enemy is attacking, we'll just remove the damage receiver here. Okay, I think that's it. So now we'll just need to set it in the code, and for that, let's hop over into the character scene, and let's do that in the process function so that our damage emitter is monitoring if we are attacking. And I think we may need a function to specify if we're attacking, so let's hop over into the can methods here, and func is attacking. And here, what are the states where we can be attacking? Well, we have the attacking state, which contains currently a couple of animations. We'll also have the jump kick. So if we are in any of the states, then we will go ahead and do some monitoring. Otherwise, so is attacking. Otherwise, let's also calibrate the damage receiver and say that this is monitorable only when we can get hurt. Okay, and this should fix the fact that knives can still hurt you when you're down. So let's go ahead and try this out. Okay, that wasn't a good test. Let's try it again. I want to throw two knives, one knife at the person, one is on the ground. There we go. And so now the knives goes above the character. And this is going to be it for this episode. We finally got our first weapon fully working end-to-end. And I know it seems like a lot, but the next collectibles and weapons will be able to reuse a lot of the same code, so it will actually be much faster to implement them. We also introduced a design pattern called the event bus, which we'll be reusing multiple times in the next episodes. If you have any questions about anything we've done today, just pop them over in the comment section below, and I'll do my best to respond quickly. Thank you so much for watching this series, and I hope that this is allowing you to understand a little bit better how to use Godot. If you do like this content, you want to see more of it, please use the like and subscribe buttons. Once I reach 1,000 subs, I'll have you pick the nature of the next tutorial series. Time to take a quick break, and I'll see you in the next episode. Cheers!